Okay, welcome to week 3. This week we're going to take a look at container construction, that is, how to build lists, tuples, sets, and dicts using construction or constructor functions. We're also going to take a look at what are called comprehensions, which is a very Pythonic way of creating lists, sets, and dictionaries. It turns out that you cannot use a comprehension to create a tuple, but we'll show you a workaround for that. We're also going to take a look at how to interact with files, that is, how to open and read from text files, and also how to open and write into text files, and how to process the lines contained within text files. And we're going to take a look at how to define and call functions and the various different arguments that you can pass into functions. There are both what are called positional parameters as well as keyword parameters. Finally, we'll take a look at the NumPy module that provides very efficient vectorized mathematical computations, random number generation, linear algebra facilities, and other things. So off we go. Now, we've looked at conversions for the low-level data types. We've seen that you can convert a string that's in proper format to an int, or a string that's in proper format to a float. All right, so here's 1.23 times 10 to the 5th in a string converted to floating point. We can convert an integer value to a str, and so on and so forth. We can do the same kind of thing for these collection types: tuple, list, set, frozen set, and dict. The idea here is that we specify an iterable as an argument to the constructor function, and the function will create the appropriate kind of collection from that iterable. So if I say t1 gets a tuple from this iterable, this is a test. All right, now a string is an iterable, and as an iterable, what's going to happen is it's going to be broken up into one-character substrings. Consequently, T1 is going to be a tuple of these one-character substrings. And there are 14 characters, including, of course, the empty spaces between the words taken from this iterable string. Now, if I create a set from an iterable, okay, T1 is a tuple, and therefore T1 is an iterable. If I create a set from an iterable, I'm only going to have one unique copy of each value from that iterable in the set. And the order of those items is arbitrary. So here we have ASH space EIT as the result on my system during this session for the contents of S1. Now notice when I wrote these notes that the output was produced in a different order. All right, so the order of items in a set is arbitrary. Similarly, I can create a list from an iterable. Let me create a list from the set S1. S1 is an iterable. And it happens that the list is created in the same order that I was shown the elements from the set. I can, with a list, invoke the sort method, which will sort these one-character strings in ascending ASCII order. And now it turns out that in the ASCII character set, the space character comes ahead of all of the lowercase letters, and the lowercase letters are ordered from little a through little z. The capital letters, by the way, are also ordered from capital A through capital Z, but all capital letters come ahead of all lowercase letters. So if I were to say v1 dot append, well, let me say v1 dot extend so that I can give an iterable. All right, so here I'm extending my list by saying help exclamation mark. v1 is now going to have those one character substrings, capital H, E, L, P, exclamation mark, appended on the end. And if I now sort this list, what happens is, all right, it turns out that the exclamation mark comes ahead of the uppercase letters, and the uppercase letters, which are in ascending alphabetic order, come ahead of all of the lowercase letters, which in turn are in ascending alphabetical order. Here we're showing that you can create a frozen set from a set. Well, actually from a list, but let me create one from a set. If I wanted to use S1 as a set that I could use as a member of some other set or as a key in some hash table, a key in some dictionary, I can say FS1 is a frozen set with the same items. Now, interestingly, you'll notice that S1 came out in this order, ASH and so on. The frozen set comes out in a different order, so although the items are the same, the order is arbitrary. All of these construction functions require an iterable, and so this can sometimes be a little confusing. You might think it's obvious to be able to say, I want v2 to be a list containing 1, 2, 3, 4. That seems like an obvious thing to want to do, but the integer 1 is not an iterable, and the integer 2 is not an iterable, so I'm going to get yelled at here that this is not appropriate. The list construction function only wanted one argument, but I gave 4 individual int arguments. I can patch this up by doing 2 different things here, or probably several different things. One thing I can do is to force this argument to be an iterable by just putting parentheses around it. All right, so the outer parentheses here are for the function call, and the inner parentheses make this thing a tuple. All right, so now this is legal. The other thing I can do is to just use square brackets rather than the constructor function name to get my list directly. Okay. These collections of individual values are easy to create from simple iterables. Since a dictionary has key value pairs, it's slightly more complicated to create a dictionary using the dict constructor function. A dictionary can be created from an iterable as long as that iterable produces so-called two-tuples, that is, a sequence of pairs of values. As one really small example to illustrate how this thing works, let me create a set of two-tuples. And this two-tuple is going, or this set, excuse me, is going to contain A as a key and 12. Also B as a key and 22. Okay, so I have now created a set of two-tuples. In this current session, those two tuples were stored in the set in the same order that I defined them, whereas when I was writing the notes, it came out in a different order. So I won't keep repeating this, but of course the items in a set are always in some arbitrary order. Now, when I say D1 gets a dictionary built from set of two tups, the dictionary constructor goes through that set, and for each pair of values, for each tuple in this case, uses the first item as the key value and the second item as the value associated with that key. So D1 now is going to have A as the key with 12 as a value and B as a key with 22 as a value. Okay, so this is what the documentation says about creating dictionaries from iterables, so that the iterable needs to be for a two-tuple. In fact, the iterable only needs to refer to arbitrary pairs of values. Here I'm saying list of two-stars. This is a list rather than a set. And in here we have a 2-character wide string AB and another 2-character wide string CD and a third 2-character wide string EF. Well, it would help if I could type. I need to remember my assignment operator. All right, so now we're good. This looks very little like anything to do with set of two-tups. But notice that a list is an iterable, and the items in this list are iterables that have 2 items in them. Each of the items in this list of 2-stars is a 2-character wide string, and that can be split up into the first character being the key and the second character being the value. So this also will work to create a dictionary. Okay, so list of 2-stars is an iterable. The first item in that iterable is the string AB, and that is an iterable on 2 values, so it gets split up into A being the key and B being the value associated with the key. Then we have C as the key with D as its value, E is the key with F as its value. Well, these couple of examples that I showed of creating a set of 2 tuples and a list of 2 strings are somewhat artificial. It's more common that you would have 2 separate iterables, 2 separate lists, or a list and a tuple, or a list and a string, or a range and a string, or something like that. And you would like to be able to use these, respectively, as the sequence of keys and the sequence of corresponding values for those keys in a dictionary. You can zip together 2 independent iterables into an iterable on 2 tuples by using this function called zip. Let me illustrate how this works. Here we're creating, I'll just type this in and get back to you. All right, so here I have created a list V1 with 6 int values in it and a string S1 with 3 1-character substrings in it. Now, it turns out that because these 2 iterables have different lengths, it's the shortest one, namely the S1 string Dan, that's going to determine how many pairs of values there are in the resulting zip of these things. All right, so I'm going to say for T for tuple, because zip produces an iterable on tuples. In the zip of V1 with S1, okay, so the first item of V1 is going to be zipped to create a tuple with the first item of S1. Then the second item of V1 with the second item of S1. Then the third item of V1 with the third item of S1. And at that point, there are no more items in S1, so zip stops trying to create any more tuples. And let me just print each of those tuples. Okay, so the loop runs 3 times, and I have the value 4 in a tuple with D, and then 12 with A, and 9 with N. And because this is an iterable on 2 tuples, from the result of that zip, I can directly create a dictionary. So let me say D gets zip of V1 and S1. Whoops, I forgot to create the dictionary. So So let me add the dictionary creation part. I got a zip object rather than a dictionary. All right, so I want this to be a dictionary. And D now is a dictionary with 4, 12, and 9 as keys and DAN as corresponding values. This one in slide 41 is just a little bit longer. It's the same idea. V1 is still the same values as I had before, but this time maybe I have a tuple of student names. All right, so Al, etc. Okay, so Al, Bob, Cy, Dan, and Ed. Now, because each of these two iterables, V1 and T1, are 6 items long, I will get a resulting sequence of 6 tuples when I do the zip. And now I'm going to create the dictionary D1 from the zip of T1 and V1. Here I've chosen to put the student names as the keys and these numbers as values. Whoop. Okay, so here we are. So we have the student names as keys and these numbers as values for the associated with those keys. Another nice function that you can use to, among other things, build a dictionary is enumerate. Now, enumerate creates an iterable from some existing iterable in which each item of the existing iterable is paired with a sequential integer value, 0, 1, 2, and so on. So let's take a look at a simple example. I have S1, Dan, and if I enumerate Dan, if I enumerate S1, enumerate is going to return to me an iterable over tuples. 0 with the first character in the string S1, 1 with the next character, 2 with the third character, and so on. For this example, S1, that's going to be it because there are only 3 characters. But if I had S1 as a much longer string, then this enumeration would be as long as necessary. I have my tuple T1 still around with student names in it. Whoops, I just noticed I made a dumb mistake, which you probably noticed and didn't care about. V1 actually has 6 items in it, but T1 only has 5 items in it. So when I created this dictionary, I ended up with 5 items in my dictionary, and this final value 6 was lost when I did this zip. Now I'm going to change D1 to refer to a new dictionary that I'm going to create as an enumeration of T1. And so now I have the sequential integer values 0, 1, 2, 3, 4 as the keys associated with these student names. Sometimes it's useful to just have a count for each record that you're processing. Enumerate is very useful for that. If you have some kind of iterable, such as our iterable T1, this tuple of student names, you can automatically generate a record number or a line number for each one of those things by using enumerate. Here, we're stepping through all of the items in T1, and we're giving sequential integer values to each one of those records, each one of those strings in this case. Remember that I can use multiple assignment to create separate variables for the enumeration value as well as for the string value that we're reading from this tuple. So here I'm enumerating the tuple of student names T1, and then I'm using I and S to contain the enumeration number and the student name in this for loop. All right, so I print out name 0 is Al, name 1 is Bob, etc. There are other ways of creating dictionaries as well, but we're going to be content with what we've already talked about as far as this class. Okay, so that's the construction or constructor functions, list, tuple, set, and dict, that you can build using iterables as arguments. The next thing we're going to take a look at are what are called comprehensions, starting with list comprehensions, and then we'll also see that you can do set and dict comprehensions as well. So far, if we've wanted to create a list with some values in it, the simplest way for us to do that is to give a variable name to refer to the list, and then an assignment operator followed by square brackets and the values in the list. So here on slide 46, we just have v1 referring to a list of the squares of the first 5 integer values, 1, 4, 9, 16, and 25. Okay, well that's fine if our list is really short and if we know the specific values that we want to put in the list. But what if we needed to have the squares of the first 1,000 integer values? Well, we could do something like this. We could say, let's just start with an empty list. Here v2 is referring to our empty list, and we'll use a loop to build up this list for n in range of 1,000. No, this is fine. I was going to say I've made a mistake because this range only goes up to 999. In particular, this range goes from 0 up to and including 999, but that's okay. We can, to v2, append n plus 1 squared. And so our range goes from 0 to 999, but our squares are going to go from 1 squared to 1,000 squared. And it just takes a moment for that to complete, and sure enough, we have this very long output of 1,000 squares. Okay. Now, the idea of a comprehension basically is to put the for loop inside of the square brackets instead of after the square brackets, if you will. So in this case, I'm going to create v3 as a list comprehension. N plus 1 squared will be the expression that specifies what value each item from the list should be, or in this new list should be. And then my loop is going to specify the range of values that n will be set to. Okay, so we have square brackets surrounding the comprehension. The first thing that we do in the comprehension is to specify the expression that is supposed to be evaluated for each item that's going to be in my list. And then following that, we're required to have a for loop that presumably will specify the number of values and in some way the values of the values of these expressions. All right, so the number of values that we're going to have in this comprehension is 1,000. Specifically, they go from 0 up to 9999. And for each particular item, we're going to use the current value of n from the for loop to compute the particular item value that we want. All right, so that's just a long way of... Now, what did I do wrong here? I see. I hit a square bracket by accident before I hit the enter key. I think that nevertheless created v3 okay. Yes. And rather than trying to display v3, I'm going to just show that v2 and v3 are equal to each other in terms of values. Now, that does not mean that v2 and v3 are the same object. v2 is, v3 is false. All right. Here's another example in which we're using a string as an iterable for our for loop rather than the range. v4 is going to be, the expression value here for each item in v4 is just going to be c for c in some string. Pythonic. Okay, so comprehensions are considered to be the Pythonic way of creating things like lists and sets and dictionaries, which, as I said before, means that it's cool. And it's also a mechanism that Python provides that other languages don't necessarily provide in as convenient a way. So again, the idea here is that we're going to loop through this string, Pythonic exclamation mark. C is going to take on the value of each one-character substring, one at a time, and that value is then going to be used as an item value within v4. So v4 now contains a list of all of the one-character wide strings from the string iterable Pythonic. You have to have a for loop in order for something to qualify as a comprehension. So for a list comprehension, the general form looks like square brackets containing some expression which specifies how each item within the constructed list is to be computed. Then we have some for loop stepping through the values in some iterable. Now, you'll notice here that we say vars rather than var, because the iterable itself might be an iterable on tuples or an iterable on lists or an iterable on sets or something, and you can use multiple assignment to create multiple variables corresponding to the individual items within that, let's say, list of 2 tuples or list of 3 tuples or whatever you're stepping through. Optionally, you're also allowed to have more for loops or if decisions to specify nested loops for the expression values to be computed, or to specify, in the case of an if decision, whether the expression should be created at all. Let's take a look at some examples of these. Here we have a really simple example. My expression is 7. So regardless of how many items there are in my iterable, and regardless of what those values are, every single time I get a value from my iterable, the expression that's going to be put into the list that I'm creating is just 7. For I in range 5. So range 5 is my iterable. I is going to take on these values 0, 1, 2, 3, 4. And for each one of those values, the expression is going to be 7. So all this does is to create a list of 5 items with value 7. I can create a list of Booleans. Here I'm saying n less than 2 as my expression. So for each possible value of n, where n is going to be my loop variable, if the value is less than 2, I'll have a true value in my list, otherwise false. So for n in range 5. All right, well, 0 and 1 are less than 2, so I should get true for the first 2 items and false for the remaining 3 items, and indeed that's what I get. In this next example, we have a loop through a string, a bit like the Pythonic example that we just saw on the preceding page, but this time we are appending an optional if following that loop. So we're going to get the value of a character that is a 1-character wide string for C in the string hello, but only if the value of the current 1-character wide string is not a lowercase l. All right, so I have 5 1-character wide strings in hello, H-E-L-L-O, and for each one of those values, we're first going to check whether that value is not L. If that value is not L, then that's going to become one of the items in my list. But if the value is L, that value is going to be ignored. Consequently, my list is HEO, and the two L's are not included in the resulting list. In this fourth example, my expression is a simple computation, k over 2. I'm going for j in range 5. So j is going to take on the values 0, 1, 2, 3, 4. But notice that the expression k over 2 does not involve j. Instead, what we have here are nested loops where k, the variable the expression uses, is taken from an iterable consisting of a range from 0 up to but not including whatever j currently is. All right, so the first time through the first for loop, j is going to have the value of 0. And that's going to control the second loop, which controls the value of k. So the second loop here, the inner loop, is going to set k for the values in the range from 0 up to but not including 0. Aha. Well, so a loop going from 0 up to but not including 0 does not do anything. The loop terminates before anything occurs. So for the first value of j, in the first loop, the outer loop, where j is 0, the inner loop does not do anything. We go back to the second value of j, which is 1, and that now controls what happens in the inner loop. So k goes in range from 0 up to but not including 1. All right, well, 0 up to but not including 1 is the single value 0. So that value for k, which is 0, is used to compute the first item in our resulting list, 0 over 2, which is going to be 0.0. Division always yields a float. Okay, and the inner loop now is finished because k only loops on 0 up to but not including 1. The third time through the loop on j is going to have a value of 2. And in the inner loop, we're going to set k to range from 0 up to but not including 2. Consequently, k is going to take on a value 0 first, which will give us this 0. And then k will take on a value 1 next, which will give us 0.5, 1 over 2. And that's the end of that inner loop on k, going from 0 up to but not including 2. The fourth time through the loop on j will take on the value 3. And so k will go from 0 up to but not including 3. That is, k will take on the values 0, 1, and 2. And from there we compute these next 3 items, 0, 1/2, and 1. The final time through the outer loop, j will have a value of 4. K will loop from 0 up to but not including 4. And that will give us these 4 final values, 0.5, 1, and 1.5. Okay, so the bottom line here is that a comprehension can involve nested loops. And the iterable on the inner loop can depend on the current value of the outer loop's loop variable. So these comprehensions can be quite compact and quite flexible. Okay, so we confirm that this comprehension actually does what's shown on slide 49. Now, not only can the for loop part be relatively intricate, for example, using a for loop with an if, or using an outer for loop with a nested inner for loop, but the expression itself can also be arbitrarily complicated. And here on slide 50, we're showing a comprehension in which the expression part is itself a comprehension. All right, so notice that we're creating a list comprehension here using an expression followed by this red for loop that's contained within the black square brackets. But the expression in blue is itself a list comprehension in which we're computing an expression, I plus j, with a for loop for I in range 4. So what we have here is a list comprehension using this red for loop that's going to create a list of 4 items for j going from 0, 1, 2, 3. But each item within that list of 4 items is a list of 4 items in blue, with I going in the range 0, 1, 2, 3. All right, so here in the result that I have VV1 as a reference to this result, the outer square brackets correspond to the black square brackets for the outer level comprehension. And then each of the items within that outer level comprehension is itself a list of 4 items. Okay, so let's see why we get these particular values that we get. Well, so the red for loop is controlling the overall construction of this list. And j is taking on the values 0, 1, 2, 3, one at a time. The first value for j is 0. And with j set to 0, we evaluate the blue expression. In the blue expression, what we have is a list comprehension. The item value within that list comprehension is going to be I plus j for I going from 0 up to but not including 4. Okay, so j's value is 0. I's first value is 0, so 0 plus 0 is the first item value in the first list within the list being created by j. Okay, so we get a 0 plus 0 is a 0. Then j is still equal to 0. I's value becomes 1. And 1 plus 0 is a 1. The third time through the blue for loop, I's value is a 2. 2 plus 0 is a 2. And the final time, 3 plus 0 is a 3. We are now done creating the first item, which is a list, in this outer list of items. So we're ready to go on to the next value of j, which is going to be 1. And that allows us to build this next item, which is itself a list of values 0 plus 1, 1 plus 1, 2 plus 1, 3 plus 1. So that gives us a list 1, 2, 3, 4. And then the third time through, j's value is 2. And so for the third item, we get this list 2, 3, 4, 5. And finally for the fourth item, we get this list 3, 4, 5, 6. So what we're creating here is a list of lists by using a list comprehension for each item inside the outer list comprehension. And I'm just going to type this in to confirm that it does what I claim. More space available to me in my idle shell, so I'll just go ahead and type the whole thing on one line. And VV1 is indeed a list of lists. On slide 51, we're doing another list comprehension, but this time we're creating a list of tuples rather than a list of lists. Notice that I'm using parentheses here to create a tuple for each item in this list being generated from the red for loop on j. Okay, so j again here is going from 0 up to 3, and the first tuple is going to be integer powers of 0, 0 to the 1, 0 to the 2, and so on. Then the next tuple is going to be integer powers of 1, which are all 1, and then integer powers of 2, 2, 4, 8, 16, and finally of 3, 3, 9, 27, and 81. VT1 sub 3 is going to be the fourth. The sub 3 tuple is the last tuple in this list of tuples. And the sub 2 item in there is this item 27. So again, let me go ahead and type that in to confirm that it really does what I claim. And I can type it all on one line. Okay, so there is our list of tuples. VT1 sub 3 is the sub 3 that is the final tuple in that list of tuples, and VT1 sub 3 sub 2 is the sub 2 that is the third item within that tuple, within that list of tuples. Well, so we've made it through list comprehensions. A list comprehension, as we've seen, consists of an item that's computed for each value in some iterable. So the list comprehension requires you to specify an expression to be evaluated for each item and a for loop over some iterable specifying how those list items are supposed to be computed. Optionally, that for loop may have an if decision. Optionally, that for loop may have another for loop, creating nested for loops, or in fact some sequence of those. You can have a for loop followed by an if, followed by another for loop, and another if, and etc., etc. The expression itself may be arbitrarily complicated. The expression itself may be a list comprehension, or maybe a tuple, or maybe a set, or maybe whatever. Now, to create a set comprehension, you do exactly the same thing that you would do for list comprehension, except for two changes. First of all, we use curly braces around the set comprehension rather than square brackets as we used for a list. Secondly, we have to be careful that each item that we want to put into our set is hashable. So we could not create a set of lists or a set of dictionaries or a set of sets. But we can create sets of ints or strings or floats or sets of frozen sets if we wanted. Here we have an example where S1 is being created using a set comprehension. Each item in the set is going to be the value of this expression C, and our for loop is going to set the variable C one by one to the values in this iterable, hello world, but only if C is not in A-E-I-O-U. That is, only if C is not a lowercase vowel. Okay, a string is a kind of collection. We can use in or not in to check whether something is in or not in a collection. And so we're going to end up with the set S1 containing all of the values in hello world, only one time each, except for the lowercase vowels. And what I end up with is L, D, H, R, space, comma, and W. Only one copy of each of those. And in the final example here on slide 52, we're showing the idea of trying to create a set comprehension where the items are lists, and if we try to do this, we're going to get yelled at because lists are not hashable. It's also possible to create a dict comprehension. Really, the only thing different here between a list or set comprehension and a dict comprehension is the form of the expression. You do have to use curly braces to create a dict comprehension. What differentiates that from a set is that the form of the expression needs to be a key and then a colon and a value. The key has to be hashable. The value can be anything that you like. So here, my for loop is the int values 5 up to but not including 10. And the items that I'm putting into my dict are the value of n as the key with a list containing the square and cube of that value as the values associated with that key. So the key 5 is associated with the list of values 25 and 125, the key 6 with 36 and 216, etc. If you attempt to create a tuple comprehension using parentheses, you don't actually get a tuple. What you get is something called a generator. A generator is a kind of iterable that will produce for you the values of the expression part ahead of the for loop part. So it's almost like a potential comprehension, but you can use the generator in any context where you could use any other kind of iterable. So if I say G1 gets the expression C for C in hello in parentheses, G1 is this generator object. If I want an actual tuple, we know that I can use the tuple conversion function with an iterable, and I can use my generator object as an iterable, and so now I have the tuple containing hello.